Okay. First, let's do a little bit review before we continue with the trigonometry substitution. In the test 1, we have a problem which is find the length of. So review. There's one problem. Find the length. Sorry. Of a arc length of a function.
Because we can't see your computer.
Oh, my bad. Yeah, sorry. I forgot to switch that. Oh, yeah, now it's much better. Wait, can you say it? Nope. Sorry. Oh, good. So in the previous class, we have in the test we have one problem is find the arc length of a function y equals square root of 4 minus x squared and x from 0 to positive 2. Okay, do you still remember this question, this problem? Okay, and what we did, we used the arc length formula. Okay, so the arc length formula is from. Okay, I would like to ask the students if anyone can tell me. Can anyone tell me the arc length formula?
Square root of 1 plus the derivative of f of x.
Okay, from a to b square root of 1 plus the derivative of fx. Just that?
Squared.
Okay, very good. Prime over x and square and dx. Okay, thank you, Taylor. So we have the arc length formula. So what do we do here? We take the derivative on the first on this equation on this function. So fx equals 4 minus x squared. Square root is 1/2 power. Now we did I think yesterday Luke helped me find the derivative of this one. We got the derivative of this one is half of 4 minus x squared times negative 1/2 times 2x negative 2x. Okay, so I think this one we did this one yesterday. Let's just do that. And then x square root of 4 minus x squared negative. All right, so derivative. Then we plug this one into the formula. We have our, yesterday Luke helped me to find out this one. Then we plug this one back into the formula. We have the boundary is from 0 to 2. And then this is the axis from 0 to 2. This is a question we did yesterday. And we use the formula to do this, right? Okay. So 0 to 2. And then we plug it in is 1 plus the square of the derivative is x squared, 4 minus x squared, and dx. Okay, we did this one yesterday as well. And then we got 0 to 2. We simplified, combine these two. We got combine these two common denominator. Okay, we got 4 over 4 minus x squared, if you remember. Okay. And then what we got is, you can take the 4 out, is 0 to 2 square root of 1 minus 2 square minus x squared dx. Okay. And then we use the formula to find the arc length. We have the formula, which is the formula of 1 over square root of a squared minus x squared dx. Okay. So can anyone tell me what is the integral of, what's the derivative of square root of a squared minus x squared dx? Jasper? Is Jasper here? Yeah? Could you please tell me what's the integral? When you answer, you have to press the button if you can.
1 over a.
Okay, 1 over a.
Or sine.
All right, so.
Not 1 over
Oh, not 1 over a. Perfect. Okay. Very good. Thank you very much. And also, I think I would just want to ask anyone if anyone remember this. We use that a lot. 1 over a squared plus x squared. 直接 If you answer, you have to press the button.
1 over a.
1 over a.
Arctangent.
Arctangent. What is tangent inverses again? Just okay. X over a. Very good. Perfect. Okay. So here we can just apply the formula directly here, right? And then we finish that. We find the length, which is pi in the end. Okay. But now today we're going to have another way to do it. Yesterday I did a little bit, but today we're going to focus on the integral of this one. We're going to use trig substitution to find this antiderivative. Sometimes you don't remember the formula. There are too many integral formulas. You cannot say LL and remember all the formulas. But if you memorize a lot of ways, methods, integral by parts, trigonometry substitution, or other substitution method, you can do it even you don't memorize the formulas. So today we're going to continue with the trig substitution. Okay, so thanks 8.4, 8.3, 8.4. Okay, trigonometry substitution. Okay, so the trigonometry substitution, we have a form, which is whenever we have the form like a square root of a squared minus x squared, or square root of a squared plus u squared, and the square root of u squared minus a squared. It doesn't matter if it's in the denominator or its numerator. Okay, whenever you have the forms like this, for example, this one, you can tell that you have what? A squared minus x squared, square root, right? Then we try to say if we can use trigonometry substitution to solve the integral. Okay, all right. So now, when we use the trigonometry substitution, well, we have to then which kind of substitution we are going to use. Okay, are we going to use sine theta, cosine theta, tangent theta, cotangent theta, or secant or cosecant, right? So we have to find out which one we're going to use. So now, which one we're going to use for three different formulas for three different square root? We have different substitutions. So first, I want to if anyone can tell me the trigonometry identity between sine and cosine. So sine square plus cosine square equals 1. Very good. Thank you very much. Okay, so from here, we can do 1 is cosine theta square equals 1 minus sine theta square. Okay, and then next one is 1 plus tangent theta square equals secant theta square. Very good. Thank you very much, Lacey. So we got tangent theta square equals secant theta square minus 1. Okay. And from this one, you can easily tell that you have a square minus 1 square. Can anyone tell me? So for the first one, which formula I'm going to use? Well, maybe, yeah, this is the first one. Okay. Either the first one or the second one. Which one do you think I'm going to use? This one or this one? The first one or the second one? It's a squared minus x squared. What do you think? If we have square root of a squared minus x squared, so which one are we going to use? Which formula will we possibly use can solve that integral? For example, this one. So which one do you think we're going to use? The first one or the second one?
Would we use the first one?
Would we use the first one? Very good. Okay, so let's finish this example with the trigonometry substitution. We got this 2 0 to 2, and it's 1 over square root of 2 squared minus x squared dx. Let's do trigonometry substitution. Okay, continue. Alright, so now first, since if we use cosine theta equals 1 minus sine theta squared, so what do you think I might need to substitute x? So I substitute x equals, what do I substitute? X equals what? So can anyone tell me what x would be? Luke?
X would be sine theta.
Would be sine theta. Are there any other different questions? So any other different ideas?
Would be sine squared theta.
Will be sine square theta. Alright, so here's 2 square x square. So let's just do a little bit work. If we use sine theta square, what happened? So I'm going to have square root of 2 square minus sine theta square. Can't get rid of the, can use the formula, and yes, we can. It's going to be 4 minus sine theta square. Well, if you use 1 minus sine theta square, you have 3 minus sine theta square. Sorry, because you have it's 1 minus sine theta square, right? It's 3 plus cosine theta square. Does it work? It does not really work, because eventually I want to get rid of the square root, right? I want to simplify it. So apparently we want to change another one instead of sine theta. Any different? Huh? Zijian, could you please, if you, yeah.
Square root 2 sine theta.
Square root of 2 sine theta. Very okay. You say square root of 2 sine theta?
No, the sine is outside.
Oh, sine is outside. Okay, let's try it. So do 2 square root of sine theta.
Square root 2.
Oh, like that. Okay. Square root 2 sine theta, right? Yeah. Okay. So let's try this one. So if we have x equals square root of 2 sine theta, what do we have is, okay, just do a quick estimation. We have 1 over square root of 4 minus square root x squared is square root of 2 squared is 2. Sine theta is sine theta squared. Does it work?
Just 2 sine theta.
Can you press the button? Thank you.
Just 2 sine.
Oh, just 2 sine theta. Why is just a 2 sine theta?
Because that would be 4.
Can you press? Yeah.
Because the coefficient would be 4.
Very good. If I use 2 sine theta, then the coefficient will be 4. Then we can continue. Well, if we do the substitution, we have to substitute the x and theta at the same time. So we take the derivative on both sides. So dx, d theta. Can anyone tell me what's the dx over d theta? Lacey? I think you pressed the button. Yeah, 2 cosine theta, very good. So we got dx equals 2 cosine theta d theta. Okay. So now the reason we have to do that, because if we substitute x, we also have to substitute the dx. Okay. So what do we have is, we plug it back in now. Okay. Oh, we're not ready yet, because if we substitute the x and the theta, we have to substitute we have to take care of what? Because if we change the variable, which part also has to be changed? Can anyone tell me? When you do the u substitution, at the same time you have to change the boundaries. Very good. Thank you very much. Then we did x equals 2. Then theta will equals, so x equals 2, so 2 sine theta equals 2, and theta will be equals, sine theta equals 1, theta will equals pi over 2. I think everyone knows that, okay? So x equals 0, and sine theta equals 0, and theta equals 0. So now we did everything. The boundaries, and also the x and dx. So now we're ready to substitute. Very good. So 2. Okay. So can anyone help me to finish the rest of the substitution process? Let me see. Nicholas, could you please help me to finish the process?
I try.
Okay. So first a theta, the boundary, pi over 2, and then pi over 2 is here, and then the bottom 0, x equals 0, theta equals 0. Very good. Then 1 over, and we just sorry, we have not done that part yet. Is 4. Oh, we don't have to. We just substitute it. So square root of 2 squared, which is 4 minus x. Now we just did x equals 2 sine theta. So x squared would be
4 sine theta.
very good. Yes. And then dx, we just finish that. 2 cosine theta d theta. Perfect. Yes. So I would still need your help to finish the whole thing. Okay. 0 pi over 2. So 1 over 4 minus 4 sine theta squared, which equals, we simplify this part. We take out the 4. Very good. So square root of 4 equals 2. Very good. Square root of 1 minus sine theta squared, which is cosine theta squared. Then we take a square root. It's just a cosine theta. Okay, right? You know that. Right, so 2 cosine theta. Okay, so now we continue. What do you see? Oh, very good. That's what we need. Okay, we have a very simple one. And 2 cosine theta cancel out. So from 0 to pi over 2. And then we just have 1 d theta. So now, what the answer would be? The antiderivative of 1 will equal theta. Very good. Then plus, then plug the pi over 2 and 0 in. So if I plug pi over 2 in, Nicholas, can you help me to finish the rest? Yes. Minus. Yeah, minus 0, and the answer is pi. Very good. Okay. This is how we use the trig substitution instead of, for example, if I totally forgot my formulas. So now we have a way to do that. Just use trigonometry substitution. We know the final answer is pi because this is just the 1/4 of a circular. Okay, so the circumference of the whole circle is c equals 2 pi r, and then the radius is 2. Okay, for example, let me forget the previous. Okay, so the equation is y equals square root of 4 minus x squared. So and x equals x belongs to 0 to 2. Okay, I think yes, we discussed that the shape of this arc is just 1/4 of a circle. So the circumference of a circle is 2 pi r. Then the radius of this circle is 2. So the circumference of the circle is, we plug 2 into the formula, we got the circumference is, can anyone tell me?
Pi.
4 pi, very good. Okay, so now it's just 1/4 of the circumference. Okay, then the arc length is just 1/4 of the circumference. So it's 1/4 times 4 pi, which is pi. Okay, we got exactly the same answer. Right. So this is the trigonometry substitution method. And also, sometimes if you know the geometric function, we discussed this yesterday. There is a geometric shape of this function. Then you can check both ways. All right. This is how we do mathematics. We have many different ways. Look at the geometrical way, algebraic way. We have many different ways to look at the same problem and solve the same problem. We will have the same answers. Okay, so which is very good. Now I would like you to practice another problem, another example. Okay, by yourself. Okay, so before I continue the example, I will give you a little bit of summary of what we did. So for the integrals involving square root of a squared minus u squared, which is square root of a squared, 2 squared minus x squared. We have this example right here. If I square root of a squared minus u squared, we are going to let u equals, I would like Zhijian tell me what do you think u is here. A sine theta, very good. Yeah. So previously, if it's 2 squared minus u squared, we got x equals 2 sine theta. Now it's more general form. If it's a squared minus u squared, I got u equals a sine theta. Okay, it's more general if we have this form. Then what do we do? We take the derivative on both sides. So du over d theta equals a cosine theta. Then we got du equals a cosine theta d theta. Okay. Now what do we have for the square root? Because we can substitute the u equals a sine theta, so the square root will be a squared minus u squared, which it would plug in. So u squared is a squared sine theta squared. Okay. Then if we plug it in, we get a squared minus a squared sine theta squared. We can simplify that, use the trigonometry identity formula. We got this will equals Bella, could you please help me to simplify this part? Take out a. Very good. You have 1. Oh, you did it quick. Okay, so your final answer is just 1 minus sine theta squared, and then you're putting a cosine theta. Very good. Okay, it's a times cosine theta. So now theta u equals a sine theta, and we just theta equals negative pi over 2 to pi over 2, because this when theta belongs to negative pi over 2 to pi over 2, you get sine theta is from negative 1 to 1. Okay, you get all the values from negative 1 to 1. All right. So now when we do the substitution, this is the general form of substitution for square root of a squared minus u squared. Now I want to do one more example. I would like you try to practice yourself. See if you can get it. Okay. Square root of 16 minus x squared x dx. Okay. So I would like you to try, give you 2 minutes and let you to practice. See what you got. I'll ask you questions, okay? Give 2 or 3 minutes to practice one by yourself. Okay, I think you all most of you should get at some point, and you don't know how to continue. Okay, so I think that's why should be enough right now. And there is one point I think some of you might need help. Okay, let's see which step you got. Okay, so can anyone tell me what answer you got right now? Cosine theta of square over sine theta, d theta, right? Or 4? Okay, so this is very almost right. I think it's 4. There's a 4 in the front. Okay, let's see. You almost got this. Almost everyone should get to this part right now. Yes. Okay. So let's see what we got. Okay, let's continue. Very good. That part is which part I want you to get for right now. We're going to continue after that, say what we have. Okay, so first we're going to continue as we said in the previous general form. I want to, let me say, Eric, could you please tell me for this integral, what do I substitute? X equals 4 sine theta. Yes, very good. Could you please help me continue? Yes. Very good. Then, here. Over x. Very good. Then, perfect. And then we cancel the 4. Okay. So this is the step you got for cosine theta square, sine theta, d theta. Thank you very much. I think that's why I said that from here, some students might need help here. So, now, we can take the 4, that's the constant, we can take it out. 4 cosine theta square, sine theta, d theta. Alright, so I have a question here. Can anyone tell me what do you think I need to do to continue? That's very good. Okay, we substitute a cosine theta equals 1 minus sine theta square. Can you tell me why you want to do that? That's very good. Thank you very much. That's a perfect answer. Okay, very good. So now, if we do that, we can simplify it more. Then we can separate this one as 1 over sine theta and d theta and minus. Wait, we just won't do that. When we simplify the sine theta with sine theta, you just said it's sine theta d theta, which is perfect. Okay, very good. So now, our answer we're going to have 2 integrals. First is 1 over sine theta is cosecant theta, d theta, and minus, okay, we just do 4, because 4 is on the whole integral, so if you separate it, we would like to separate both, so 4 sine theta d theta. Okay, alright, so this one, many of you probably don't memorize the formula for cosecant theta, but secant theta is more, we use it more, like tangent theta. I will just give you the formula for this one. If you don't remember, I will ask, maybe someone will memorize it. Does anyone remember the antiderivative cosecant theta? This is a hard one, because we don't really use it a lot. Does anyone remember it? Okay, I would not be surprised if you don't memorize it, because this is the one we really don't use that often. Okay, so it's cosecant. Alright, so now the answer is going to be, for this one, let me just give you the answer. Okay, so for this one, the answer is cosecant theta is is 4 ln. Okay, it's ln cosecant theta minus cotangent x, cotangent theta. So that's why That's why I think a lot of you don't memorize this one. I don't blame you because this one we do not really use a lot. But you can, when you do in the future, when you work, for example, your engineering department, your science, you can use you can find the formulas in the end. You can use it, okay? And then, but this one, I think everyone should know it, right? So the antiderivative for sine theta. Can anyone tell me? So it's negative 4 cosine theta. Very good. Thank you very much. Cosine theta and plus c. And then the answer is 4 ln cosecant theta minus cotangent theta and plus 4 cosine theta plus c. Alright. Are we done? Are we done, everyone? The problem was square root of 16 minus x squared over x dx. Now I got an answer like this. I'm done. Is that the final answer? What do you think? Well, if for example, if I do x dx, you know the answer is going to be half of x squared plus c, right? Well, the function should be a function of x. But now what I got? My result is a function of theta. Do you think is there any problem here? Yeah, right here, all of this, I do not think we have any problem right here in the process. So by here is we have to do a little bit more work. I think you're right. You want to check right here, 4 cosine theta squared over sine theta. You probably say, okay, so maybe I can change it back. If you change it back, you're going to have the square root back again. What do you think, Lacey? Yes, very good. If you change it back, cosine theta, maybe I can change it to 1 minus sine theta squared, and then you change it back to again, the square root comes back again. But if you finish here we got the most important part we have done is that we don't have antiderivative anymore. That part is good because we have already finished the antiderivatives. We don't have integral anymore. But we still have one problem remained, is that we don't have the function we need. We don't have a theta. We want a function of x. When you do any derivative of x, and then you give me a theta, what's that? Right? So at some point I have to put this theta back into x. Okay? So how I'm going to do? This is the second important thing of the trigonometry substitution. If it is a boundary problem, definitely the integral, you will be fine. Because if you look at the previous problem we did here, if it's a boundary problem, that definitely the integral, because you will change the boundary and the final answer you will get, you just plug it in, you will have the answer. The final answer is going to be a number, a constant, right? You do not have to worry about the theta anymore. But if it's an indefinite integral, you change the x into a theta, then at this point you have to change the theta back into x. Does that make sense, everyone? At the beginning, we change x into theta into trigonometry function. Oh, it's so easy. We like trigonometry function because we have trigonometry identities. But then, at this point, we use that advantage of trigonometry function identities, which is very good. We finished the integral. But now it's time for us to change it back into the function of x. So how am I going to change it back? So this is the theta. Suppose we draw a triangle. This is what we do, right? Then, at the beginning, we let sine theta equals wait. I think we assume, let me see what we assume. We assume x equals 4 sine theta, right? We assume x equals 4 sine theta. Now, this is theta. Then I can divide both sides by 4. So sine theta equals x divided by 4. So, now I have a triangle here. I draw a triangle theta here. So now can you help me to find out the 3 sides? This triangle, this is a theta. So what this side would be? Zijian, if you know that, could you please start? 4 is going to be the hypotenuse. Very, very good. And then the opposite side is x. Very good. Lacey, thank you. What about the adjacent side? Root of 4 squared. Very good. Thank you very much. 16 minus x squared. Now, I draw a triangle here. Can anyone tell me why do I draw a triangle here? Why do I draw a triangle here? Perfect. Very good. This is what I'm doing here. Now, if I draw a triangle here, then I can match a theta, transform the theta, the function of theta with respect to x now. That's very good. That's a very good point here. Okay, so now I can just do the cosecant theta. I can just express the cosecant theta by the function of x, by the variable x now. So now I would like you to help me. Cosecant theta, if I use the x values to represent it, what would be the cosecant theta? I still. Could you please tell me? Still don't remember your name. Oh, theta. Yeah. Could you please tell me? Continue here. Cosecant theta would be 4 over x. Okay, very good. So cosecant theta is 1 over. Wait. Yeah. Cosecant theta is 1 over sine theta. 1 over sine theta is hypotenuse. Sine theta equals opposite side of hypotenuse. So it's 1 over 4 over x. Everyone got it, right? Okay. So just give a quick help here. Cosecant theta is 1 over sine, which is sine is hypotenuse over. Sorry, sine is opposite of hypotenuse. Okay, opposite of hypotenuse. All right. And then you keep changing flip, which is hypotenuse over opposite side, which is 4 over x. Perfect. Okay. So now could you please continue help me finish the rest of them? Can you press the button? Press the button. Then, yeah. Very good. Plus. The 4 will be cancelled. Okay. Alright, so then plus C. Sorry, this is 2 here and here. You can see the answer. Okay. So the final answer would be equals. Okay. The final answer would be equals 4. Wait, do I have a 4? Yeah. Okay, so ln of 4 over x minus square root of 16 minus x squared over x, and plus square root of, just write it again in case that part, x squared plus c. So this would be your final answer of this problem. which is really good. Okay, after you have the cosecant theta, you draw a triangle and map it back into the function of x. That's what you need to do for the trigonometry substitution in the end if it's an indefinite integral. Okay, this is the first one, first type of integral we did. The next one we're going to do the tangent. Since we have the background of sine theta now, we can do that one a little bit quicker. For the second one, but we can finish tomorrow. Continue that. Okay, so the second part is for the integral. For the integral involving square root of a squared plus u squared. Previously the a squared minus u squared, right? So now it's a squared minus plus u squared. Now I still give you the identities. Okay, sine theta squared equals, sorry, cosine theta squared. Identity is cosine theta squared equals 1 minus sine theta squared. Now 1 plus tangent theta squared equals secant theta squared. Okay, so now I still want to ask you a question. What do you think I would substitute a here? Or sorry, u. U is the variable. Well, sometimes you got a squared plus x squared. It's the same idea. Okay, so if you have this, what would you substitute here? Use the trigonometry. We have used this one. Now it's time to use the this one. So what would you think I need to substitute here? That x or u equals what? I will say a secant. Let's try it. Okay, there's no square. Oh, a secant, right? Lazy, right? Okay, so let's try it. See what happened. If I plug it back in, so it's going to be a squared plus a squared secant theta squared. We're going to have square root of a squared 1 plus secant theta squared. Would that be good? So what do you think? Very good. We choose tangent theta. Okay. Tangent theta. What if I use a tangent theta? So what happened with the whole integral? So with the whole square root. Then we have the square root is a squared plus a squared tangent theta squared, which is square root of a squared. Take it out, 1 plus tangent theta squared. Then we can apply the second identity, which is Lacey, could you please help me simplify it? A secant theta. Very good. Okay. So once we finish the u, we're not done yet. We also have to find the du. Okay. So du over d theta. It can be dx, du is the same. Okay. So du over d theta. What's the derivative of tangent? Anyone tell me the derivative of tangent? Or let me say the derivative of tangent. Derivative of tangent theta. Okay, you gave me a very okay, secant theta. This is the first answer. Secant theta, tangent theta. Okay, this is the first answer. I'm not gonna say it's right or not right. Okay, so d over d theta of this one equals that. Okay, this is very familiar with us, right? Because we used that a lot in the previous section. For that yes. Oh, you mean you substituted A? You said A equal. Uh-huh.
We use tan theta squared. I was asking if you can use
Oh, yeah. I just did that. So if we do A squared, if you say U equals A secant theta, so you got A secant theta squared. I think I write it here. And now what do we have is A of 1 plus secant theta squared. Is that very lazy?
Yeah.
But if we do that, the 1 plus secant theta squared, we don't have a trigonometry identity for that. What do you think? But we have 1 plus tangent theta equals secant theta squared. But if you have 1 plus secant, well, secant is 1 plus tangent. You're going to have 1 plus tangent theta squared. You have 2 plus tangent theta squared. And then the square root is still there. Does it make sense? Yeah, you got it right. Very good. Yeah, that's a good question. Because when we sometimes we just have to try it, especially it's the first time to learn this. We just try it and it's not working. Okay, now I got it. So now you got this is 2 plus tangent theta 2. Then that one does not work because don't get rid of the square root. In mathematics, we always want to simplify and get rid of the square root, right? Okay, so now the derivative of tangent theta is. Can you press the button? Okay, thank you very much. So it's A secant theta squared. Very good. So now I have a question. Since another student mentioned that d of something equals d secant of tangent. Well, if I have tangent equals secant, what would this be? Where would this one? I know it's very familiar, and sometimes I get confused. This d of what? The derivative of. Can you press the button? Yes, we did use that a lot in the previous section. Derivative of secant theta equals secant theta tangent theta. Okay, so this is the general form of this one. Okay, after you go back home, I would like you to practice. Since you have the cosine sine background, you follow the same steps. See if you can finish this example. And x squared. The integer of x times square root of 1 plus x squared dx. Okay. Tomorrow we're going to continue. I would like you to try the same steps as what we did, and then finish this one at home today. And tomorrow, bring me questions. Okay. All right. That's all for today's class. And I will see you tomorrow. If you have any questions, just feel free to email me, Skype with me. Okay. You have your test grade, and you will have your test back if you need it from. I think I'll email it to Matthew today, and you can ask him about it, okay?